everyone. Our lesson today is lesson 4 in unit 4, applications on vectors. We have some examples. Number 1, here we have triangle ABC. The vector BD is 2m vector, so the direction will be BD is 2m vector. DA is m vector. DA, the direction will be m vector. EA, n vector. And finally CE is 2n vector. Find BC vector in terms of m and n vector. First, we want to get BC vector. In the triangle ABC, as we studied in the previous lesson, BC equals what? Equals the vector BA plus vector AC. So here we have BA vector plus AC vector. Okay, BA vector equals what? Here we have this direction, so 2m plus m, it will be 3m vector plus AC. AC, the direction will be here, and we have 2n and n in this direction, so it will be negative what? 3n. We write it again, it will be 3m vector minus 3n vector. Take 3 as a common factor, we get m vector minus n vector. Okay, so here we get BC in terms of m and n. Then prove that BC parallel to DE. So we want to get BC and DE have the same magnitude, have the same direction and magnitude, the norm. So here we want to get the DE. Okay, DE equals DE in this triangle equals what? In this triangle equals what? Equals DA plus AE. So here DA plus AE. Substitution. DA equals what? DA in the same direction, it will be m vector plus AE. We have EA n vector, so AE in the opposite direction, it will be negative n. We write it again, so it will be m vector minus n vector. What did you notice here from 102? Here we have BC vector is 3 times DE, 3 times DE. And they have m minus n, the same direction. So we get here BC parallel to, from 102, BC parallel to DE. Okay, another example, number 2. Find the length of AB. Here we have triangle ABC. We want to get the length of AB or the norm of AB. So we want to get what? The coordinates of A and B. So we write here x-axis and y-axis. Here we have y-axis and x-axis. What did you notice here? Here we have A. CA is 7. So the point A will be 7 and 0. Okay, 7 and 0. Here B. We have here, a given 135, the measure of C 135. Okay, here what about B? We have here B in the polar form. Here we have the magnitude 5 root 2 and the angle which make with the positive direction of x-axis is 135. So in the polar form, B will be 5 root 2 and 135. How to convert it in Cartesian coordinates? So B equals, as we said, norm B cosine theta to get x, and norm B sine theta to get y. Norm B here is 5 root 2. Norm is the length. Cosine theta, cosine 135. And also 5 root 2 sine 135. Using your calculator, 5 root 2 100 cosine 135, it will be negative 5. 5 root 2 sine 135, it will be 5. So we get the coordinates of B. So it's easy to get AB vector. As we said, AB vector equals vector B minus vector A. So negative 5 and 5 minus coordinates of A, 7 and 0. Negative 5 minus 7, it will be negative 12. 5 minus 0, it will be 5. We get AB. Have to get the norm of AB. X power 2 plus y power 2 under the square root. Here we have rule x power 2 plus y power 2. So negative 12 power 2 plus 5 all power 2. Using your calculator, it will be 13 length unit. So the length of AB or the norm of AB equals 13 length unit. The last example, ABCD is a quadrilateral. What's the meaning of quadrilateral? Polygon consists of 4 sides. We have the coordinates of A, B, C, and D. We want to prove that the figure ABCD is a rhombus. It means we want first to prove that ABCD is a parallelogram. How to prove that any quad is a parallelogram? We have lots of conditions. First, we want to prove each two opposite sides are parallel, or each two opposite sides are equal in length, or two opposite sides are parallel and equal in length, or to get the diagonals and prove that the diagonals bisect each other. Okay, here we prove that with two sides are parallel and equal in length. Use any one. Okay, it's up to you. So first we want to get AB, the vector AB. As we said, vector AB equals what? Equals vector B minus vector A. Substitution. Vector B is 3 and negative 2 minus vector A is 5 and 3. So we get 3 minus negative 5 equals negative 2. Negative 2 minus 3 equals negative 5. So AB vector equals negative 2 and negative 5. Okay. Get DC equals C minus D. So C equals negative 2 and negative 4 minus D will be 0 and 1. So negative 2 minus 0 equals negative 2. Negative 4 minus 1, it will be negative 5. So DC here is negative 2 and negative 5. Don't get CD because we have the same, it means we have the same direction. If we write any quad like this, here A, B, C, D, we get AB in this direction, so we must get DC in the same direction. Okay, if we get BA, so of course you get CD. So here we get two opposite sides are equal in length. So we want to prove that the other two sides equal in length, which is AD and BC, or to prove that AB and DC are parallel. How to get the slope of AB and the slope of DC? So the slope of AB equals what? Y over X. It means negative 5 over negative 2 equals 5 over 2. And also the slope of DC equals 1 over X. Negative 5 over negative 2 equals also 5 over 2. So here the two slopes are equal. So we get AB parallel to DC. So here from 1 and 2 and 3 we get the figure ABCD is a parallelogram. We want to prove that this figure is a rhombus. So we want to prove the two diagonals perpendicular. here the two diagonals AC and BG. Okay, so how to get the two diagonals AC and BG? So first AC equals C minus A. C, negative 2, negative 4, minus A, 5 and 3. So it will be negative 2 minus 5, negative 7, negative 4 minus 3, also negative 7. So AC vector is negative 7 and negative 7. BG vector equals D minus B. So 0, 1 minus negative 3 و negative 2, 0 minus negative 3, it would be here, sorry, 3, okay. B, it will be 3 negative 2. So here 0 minus 3, it will be negative 3. 1 minus negative 2, it will be 1 plus 2 equals 3. Okay, so here we get AC and BG. So we want to prove that the slope of AC times the slope of BG and must equals negative 1 to prove that AC and BG are perpendicular. Slope of AC equals y over x, negative 7 over negative 7 multiply slope of BG 3 over negative 7. It will be 1 multiply negative 1 equals negative 1. So we get here AC is perpendicular to BG. So the figure ABCD is a rhombus. We have another required, find its area. The area of the rhombus equal half the product of the lengths of two diagonals. So the area of the rhombus ABCD equals half D1 times D2. Substitution, half D1 equals the norm of AC. It means negative 7 power 2 plus negative 7 power 2 times D2, the norm of BG. It means negative 3 power 2 plus 3 power 2. Using your calculator, the result will be 21 square unit because we talk about the area. Okay, thank you.